Picture an object detector drawing a box around a car, and right next to it the true box, a human carefully labeled. Here is the deceptively hard question. How do you actually score whether that prediction is any good? Your first instinct might be to check if the corners line up, but that turns out to be surprisingly misleading. Two boxes can share a corner and still barely overlap at all, or a small box can hide inside a big one and look close by coordinates while covering almost nothing. So computer vision reaches for one beautifully simple number instead. It's called intersection over union, or IOU, and you'll also hear it called the Jaccard index. This single ratio quietly powers almost every object detection and segmentation system in use today. Let's see exactly how it works, step by step. OU is really just one small calculation you can picture in your head. Walk through it once and it sticks for good. Everything starts with two regions. Take the predicted box or mask that the model produced and place it next to the ground truth region a person labeled as the real answer. That pair, the guess and the truth, is genuinely all we need to begin, and the same recipe works whether these are rough bounding boxes or fine pixel masks. Then measure the overlap. Look at the area where those two regions actually cover the same pixels, the part they share. This shared piece is the intersection, and a bigger intersection is a good early sign. Now divide by the union. The union is the total area either region covers, counting every pixel touched by the prediction, the truth, or both. Dividing overlap by this combined area keeps the score honest about size. Finally, you get a score between 0 and 1. 0 means the boxes miss each other entirely, and 1 means a flawless match. A higher IOU simply means a tighter, more accurate prediction. That single number is the whole metric. So why lean on IOU at all? Line it up against the naive way people first try to score a box. Checking whether the box corners match sounds reasonable, but it fools you constantly. A prediction can nudge its corners a little and look fine on paper while actually covering the wrong region, or a small box tucked inside a big one scores well on coordinates yet captures almost nothing real. IOU sidesteps all of that by comparing regions, not coordinates. Overlap divided by union gives you one honest match score that respects position and size together. Look, that's why it became the shared language for asking how good is this box or this mask across the entire field. Now, where does this little number actually show up? 3 roles matter, and IOU quietly plays all of them. First, the definition itself. Overlap area divided by union area. Nothing more. That simplicity is exactly why it travels everywhere, working the same on bounding boxes and on pixel masks without any special casing. Second, the clean scale. Every result lands between 0 and 1, where 1 is a perfect match. Because the range is fixed and intuitive, you can compare models directly and set a clear bar for what counts as good enough. Third, the jobs it does. Detections count as correct only when IOU beats a threshold, commonly 0.5, and mean average precision is computed by sweeping across several of those thresholds. IOU also drives non-max suppression to kill duplicate boxes, and some models even train directly on an IOU-based loss like GIOU, because it lines up with the metric far better than raw corner coordinate error ever could. Alright, let's lock in what makes IOU the workhorse metric of vision. Intersection over union measures overlap by dividing the shared area of two regions by their combined union area. Scores run from 0 for no overlap to 1 for a perfect match, so higher always means a tighter prediction. Comparing regions this way beats checking corner coordinates, which can look right while the boxes barely overlap. Beyond scoring, IOU thresholds detections and powers non-max suppression, making it the shared language of detection. If you enjoy AI ideas explained this cleanly, Standarity.com has a growing shelf of them waiting for you.